Hello, and welcome to another presentation of 5-Minute Cybersecurity. I am Bill Osolinski, a certified information systems security professional with 30 years of experience. AI presents exciting new opportunities to make our lives better, but the recent problems with ChatGPT demonstrate there are also new risks. I will be presenting examples of how AI systems can be hacked and the challenges associated with protecting them. Adversarial attacks. An adversarial attack is a type of attack on an artificial intelligence system that involves deliberately feeding the system manipulated or malicious data. The goal of an adversarial attack is to trick the AI system into making incorrect or unexpected decisions. For example, let's consider an AI system that has been trained to recognize images of objects. An adversarial attack on this system might involve adding imperceptible changes to an image, such as modifying a few pixels, to fool the AI system into misclassifying the image. The image may look almost identical to the human eye, but to the AI system, the small changes may be enough to make it recognize the object as something else entirely. Adversarial attacks can be used to target a variety of AI systems, including those used in computer vision, speech recognition, and natural language processing. The attacks can be designed to cause a range of problems, from benign misclassifications to more serious consequences, such as autonomous vehicles misidentifying traffic signs or medical diagnosis systems producing incorrect results. One of the reasons adversarial attacks can be so effective is that they can be difficult to detect. As a result, defending against adversarial attacks is an ongoing challenge for AI researchers and developers, and new methods of detecting and preventing these attacks are continually being developed. Model poisoning. Model poisoning is a type of attack on an artificial intelligence system that involves manipulating the data used to train an AI model. The goal of a model poisoning attack is to introduce false data into the training set in order to manipulate the behavior of the AI model when it is deployed. Model poisoning attacks can be difficult to detect, as the model may appear to be functioning correctly during testing and validation, but exhibits unexpected behavior when it encounters specific inputs that have been poisoned. For example, if an attacker was able to introduce false data into a training set for an AI model that is designed to recognize spam emails, the model may perform correctly for most emails, but then start identifying legitimate emails as spam if they contain specific keywords or phrases that were included in the poisoned data. The impact of model poisoning attacks can be significant, particularly for AI systems that are used in critical applications such as healthcare, finance, or transportation. A model that has been poisoned may produce incorrect results, leading to incorrect decisions or actions that can have serious consequences. To defend against model poisoning attacks, it is important to implement rigorous data quality control measures, including data validation, data cleaning, and data sanitization. It is also important to monitor the training data carefully for signs of malicious tampering, such as unexpected patterns or anomalies, and to use multiple data sources to reduce the risk of a single source being compromised. Additionally, AI models should be regularly tested against a range of inputs to detect any unexpected behavior and to identify any potential vulnerabilities. Finally, it is important to regularly update and retrain AI models to keep them up to date and to address any new vulnerabilities that may arise. Backdoor attacks. Backdoor attacks are a type of attack on an artificial intelligence system that involves inserting a backdoor into the system during its development or deployment. A backdoor is a hidden mechanism that allows an attacker to take control of the AI system at a later time. A backdoor can be inserted in a number of ways, such as by adding a specific trigger or command that can be used to activate the backdoor. For example, an attacker might add a hidden command to a voice recognition system that, when spoken, activates a backdoor that allows the attacker to control the system. Backdoor attacks can be difficult to detect, as the backdoor may be designed to remain hidden until a specific trigger is activated. In some cases, the backdoor may not be activated until long after the system has been deployed, making it even more difficult to detect. The impact of backdoor attacks can be significant, as they can allow an attacker to take control of an AI system and use it for malicious purposes, such as stealing data, spreading malware, or launching attacks on other systems. To defend against backdoor attacks, it is important to implement rigorous security measures throughout the development and deployment of AI systems. This includes using secure coding practices, implementing strong authentication and access control mechanisms, and regularly monitoring the system for signs of unauthorized activity. Exploiting vulnerabilities. Exploiting vulnerabilities is a type of attack on an artificial intelligence system that involves identifying and exploiting weaknesses in a system's design or implementation. A vulnerability is a weakness in the system that can be exploited by an attacker to gain unauthorized access, steal data, or cause other damage. Vulnerabilities can exist at various levels in an AI system, including in the software, hardware, and network components. For example, a vulnerability might exist in the code used to train an AI model, in the algorithm used to make predictions, or in the software used to deploy and manage the system. To exploit a vulnerability, an attacker will typically use a variety of techniques, such as buffer overflow attacks, injection attacks, or social engineering attacks. These attacks can be used to gain unauthorized access to the system, steal data, or manipulate the behavior of the AI model. The impact of exploiting vulnerabilities can be significant, particularly for AI systems that are used in critical applications, such as healthcare, finance, or transportation. To defend against vulnerabilities, it is important to implement a range of security measures throughout the development and deployment of AI systems. This includes using secure coding practices, implementing strong authentication and access control mechanisms, and regularly monitoring the system for signs of unauthorized activity. Additionally, regular security assessments and testing should be conducted to identify and address any vulnerabilities in the system, and any identified vulnerabilities should be patched as soon as possible to reduce the risk of exploitation. Thank you for your time.